Hey guys, Nick here from Test Me Tutoring. We're doing methods today, and we will start up in a bit. I just had Twitch open and there was a bit of reverb for my own voice. Jeez. Alrighty. So we will get started in a minute or so. We'll just wait. But basically we'll be going over some anti-differentiation today, specifically around some show that questions because they're quite difficult. And then we'll be looking at binomial, probability or distribution, and maybe some normal distribution on the end, depending if we've got some time. Okay, so again, we'll just give it a bit, we'll see. And yeah, so this stream hopefully we'll try and get this as interactive as possible. It'd be great if we had some people talking in chat. I'll be asking some questions and everything like that, and I'll probably just ask as many questions as people are replying, you know what I mean? So it's kind of your decision how interactive this will be, which is good, but I'll have some poll left questions, and I'm completely okay if people aren't comfortable putting in chat and things like that. So I've got 6 multiple choice questions that basically we'll go through today, and that we'll be able to get some feedback on and do them yourself, and it's anonymous. So I'll just quickly explain a bit about Test Me Tutoring. So I started this up a month ago, because there's some year 12s that are really, I'm tutoring some year 12s and they're finding it like pretty tough year. So I just been writing some practice exams for both further and methods at testmetutoring.com.au, just a bit of a plug there. But if you just want to go through some free practice exams, so you can submit it on the site. I'll do some marking for you just to help you guys out a bit. And now I'm doing the streams just to go over some of the difficult questions in those exams, as well as some other concepts that some of my tutoring students may have found difficult, or that I think they're more of a difficult topic. Okay. So just a bit about myself. I graduated about 7 years ago, 2013, and did a Bachelor of Engineering, Bachelor of Science at uni. So if you also have any questions at the end about uni and preferences, because I know that's coming up pretty soon, feel free to shoot us a message in chat and we can have a chat, so it'd be good. So I just completed the further maths one, that's why I got some further maths matrices up, but we might get started on methods. Alrighty. So the question on the SAC, and I'll just, the question on the exam that I think people might have had a bit of trouble with. We didn't get a whole lot of responses back, so, but this is basically a show that question. Now it's more I want to talk about the style of question that this is, because it's a really common one in methods exams, because basically we need to show a principle, and then we use that principle then to solve another, a different equation or the same equation or something like that, okay? So this one's around anti-differentiation. I'll go through this one in detail, and then we'll do another style of show that question, and then we'll do a multiple choice question, okay? So that's kind of the format that we'll work with. So this question here, show how 4x minus 7 over x minus 1 can be written as h plus g over x minus 1. Okay. Now, we don't know anything about anti-differentiation. We don't know anything about anti-differentiation just yet. So this question is pure algebra. Okay. So we know that here our denominator is going to be x minus 1, and here we have no denominator. So to be able to simplify this to just a constant, we need to have the denominator and numerator have the exact same value. So in this case, the exact same value of x minus 1. Now that might sound a bit confusing, but we need to be able to split this up into two different areas, okay? The way we've got to split it up is we need to factorize it, okay? So, what is a multiple? Actually, I'll just pause for 1 second instead. I'll give you guys a minute to think about how we could do that, and if you want, feel free to give it a go yourself. I'll give it 20 seconds or so. So specifically, something you might need to notice is this h up here, and obviously here as well. There is no x, okay? It's just h, which is a constant number, a constant without a variable attached. Therefore, when we split this up, we need to be getting rid of the x out of the left hand divisor. What the word is that I've gone blank from now, actually. So the way I work it is this 4x minus 7 over x minus 1, right? This 4x here is the part of x minus 1 that can't change. So how do we get from x to 4x? Pretty simply, we multiply it by 4, right? So we've got x by 4. What about the negative 1? We'd have to do the same to that as well. Negative 1 by 4 is negative 4. But instead of negative 4 up here, we have a negative 7, okay? But we can split this up. So now there's two ways we can do it. I'll show you both ways. There's one way that I prefer, which is we can just split up that negative 7 to have negative 4 and negative 3, because that's the exact same thing, right? Because negative 4 and negative 3 is negative 7. That has not changed that numerator. The numerator is the exact same. The bottom also stays the same as x minus 1. Now, the other way we can do it, and I'll just put it on the side here, is 4x minus 7. Then we can minus 4 and plus 4, because we want to add that negative 4 into the mix, right? And to add the negative 4 into the mix, we've got a plus a 4 as well. And that simplifies out to 4x minus 4. Then we've got negative 7 plus 4, which again is negative 3. So it doesn't change, but you can either split up the 7 or you can just tack it on the end and simplify like that. And how you going, Puda? Sorry, I just saw the chat message. So where were we? Okay, so we can now have here something that we can factorize, right? So we can factorize it by taking out a 4 as a common factor and going x minus 1, minus 3. All of that is over x minus 1. Now, what we can't do is cancel out right now. Okay, I hope you guys know that. If we're cancelling out x minus 1, we need to cancel out of everything. So what we can do is rewrite this as 4x minus 1, and it's called the distributive law, I think it is. But anyway, you don't need to know what it's called. Minus 3 over x minus 1. It's the ability to split up fractions. As long as there's a plus and a minus, we can split it up. Okay? So, equals, we can cancel now, because see, it's only the factor in the numerator. What we're left with is 4 minus 3 over x minus 1. Okay? This here is the simplification. Now, the question is asked, what is h and what is g? Another thing we might make a mistake. So if that's h, we might say h is equal to 4 and g is equal to 3, right? What we're forgetting is this here at the front. Up here it's a plus. In the question it shows us a plus, right? In the question it says a plus. In this case we've got a minus, so we need to make sure our g is negative 3, okay? Quite important, quite necessary to remember, and it's a really, really common, it's not one of the complex later questions in the methods exam. This is a exam 1, question 2, where we're dealing with anti-differentiation and differentiation, okay? So the way the exams are laid out, usually we start with that differentiation and anti-differentiation questions. Alright, now the second part of the question is, therefore, find the antiderivative of 4x minus 7, x minus 1. So that thing we started with, 4x minus 7, x minus 1. Now, this is a non-calculator exam. So if you were to try and integrate this, if we were just to go as a full integration like this, dx. If we would differentiate, we know we could use a quotient rule and everything like that, and we'd end up with, I don't know, x minus 1 on the bottom or something, x minus 1 squared. But this is integration. We don't know how to integrate with a product rule, okay? So that's where we've got to use our answer, and that's the point of these show that questions, okay? These show that questions, even if they give you a hint on how to kind of work out the questions, they kind of help you along the way. So we know we can write this one as integration of 4 minus 3 on x minus 1 dx, okay? We can just rewrite it because we know they're equal to each other, okay? We then move on and we can, I'll stay with red. The integration of 4 is 4x. Now, can anyone tell me, I'll leave it in chat for a bit, what is the integration going to be of 3 on x minus 1? Or negative 3 on x minus 1. Give everyone a bit of time. I'll give you about 30 seconds for this one. And try not to use a calculator. I know I've got a calculator up, but this is a non-calculator question. Yeah, spot on, Buddha. Spot on. 3. So you've said log. It's also written as ln, x minus 1. I think on my multiple choice I might have had an ln in there. But yeah, spot on. Negative 3 ln of x minus 1, or ln is log natural, so we can write that as log e. Okay? And that's the integration. Alright, now, that's that question complete, okay? Now, is there any other integration you kind of wanted me to go over here? Because I'll go over one other show that question, but let me know in chat if you want me to go over any other integrations specifically. There's a definite integral that I think, because I actually went over that pretty quickly, so I might bring the definite integral question over, and we'll see if we can go through that one as well, okay? But just in the meantime, while I try and find that question to bring it over, if we bring over this, if fx is equal to tan x, this is a really common show that question. Show that. This is not integration anymore, it's differentiation. F dash x is equal to 1 on cos squared of x. Okay. Again, this is more looking at the show that question itself. Explain to me, because they kind of give you the answer, right? So how do we actually get marks out of this one? And I'll give you a bit of time if you want to do it yourself. I'll just quickly find that question because it was quite a good one. It's on more integration, so yeah, spot on. Quotient rule. And Puda, what is the quotient rule? How are you going to use the quotient rule for tan x? I hope this doesn't pop up there. It does, of course. Sorry. So what do you mean using the quotient rule for tan x? What is tan x equal to? Yeah, spot on. Good stuff. So I show that question for this. It's a 2-marker. Just as quickly, sin x over cos x. We know the quotient rule is, I use u and v. I can write out the full one if you guys want, but it's v dot u dash minus u dot v dash on v squared. Plug and play with this one. We know that u is equal to sin x. V is equal to cos x. And I should have done this in order, but u dash is equal to cos x. And v dash is equal to negative sin x. What am I doing? That's an s. Negative sin x. Yeah? And then we just plug and play with that one, and what we're left with, again, in a show that question, we'd have to write it all out, but just in the, no, we'll write it out actually, just give me a sec. Cos x by cos x, and as I said this in my further stream as well, I'm making my mission for today not to run out of space anywhere, so give me a sec, because I don't know if anyone's watched my previous streams, which are up on Twitch and YouTube. I ran out of space quite a bit. Minus, and this is sin x times negative sin x over cos squared x. And that leaves us with cos squared x minus sine squared x. But a minus and a minus make a plus. I really should change colour because it's getting a bit bland, isn't it? Let's go to a white. And we know that this is what's called a trigonometric identity, and it is something that you will have to know. This is not something that's given to you. I don't believe it wasn't when I was in year 12, so maybe, I don't know if it's changed. This is called, oh, that's a sine. Oh, of course. So cos squared x plus sine squared x. There's a trigonometric base to this, but this is the identity, something you just have to know, is equal to 1. So we can just replace cos squared x plus sine squared x with 1. And that gives us that, which is also equal to sec squared. Alright? I hope that's okay. I'll pull up a Pdf question if you guys just want to give it a go. Yeah, spot on. My issue with that, I call it trigonometric because it's just, every time I try and say that, it just screws up. Pythagorean identity, there you go. Let's bring up Pdf. So do you guys want to give this one a go? I'll have a link to the Pdf here. If you just want to go on that and then oh, no one saw the answers. Everyone's looking at their own thing. Sorry, I meant to hit present. There we go. Give that a go. Again, try not to use, I'm going to leave the logo at the bottom right. It's not interrupting anything. Try not to use a calculator for this one. I don't think you can, actually. And give a go on how you'd split this one up and what A and B are going to be equal to. And I'll be honest, I haven't looked overly at these questions, so I hope I got them right. Yeah, I think I did. I think I might got A and B wrong way around. Okay, let's have a look. We've got one response. I'll just give it another 10 or 15 seconds. Also, please feel free to follow me on Twitch. I'll be doing this every 2 weeks. I don't know if I said that at the start, but every 2 weeks. I've got 2 responses. Let's have a look. Spot on. Yeah, good stuff. So we can split this up. 42 divided by 7, 6. So then we go 2 times 6 is 12. Take that as a common factor. That leaves us with 8 as B. And it'll leave us on the right, on the left as 6 as A. So assuming you guys got it correct, I won't go through it. But great work. Have we got another one? Alright. I don't even know what that's meant to say, but what's an when simplifying? It's not meant to say of when, but just what's the anti-differentiation when simplifying that? Give it a go. Being that you got the one before right, I reckon you should be sweet for this one. And I'll turn off that so we can see that. So we got one response. Got 2 responses. We'll keep going now. There we go. Spot on. C again. The tricky one with this one is it's the 8 over 7 bit. When you're simplifying it, or when you're anti-differentiating it, I'm gonna slow down. But you guys got it spot on. Alrighty, have we got one? No, we're going. That's binomial distribution. So is there anything else? I mean, we've got a bit of time. Let's bring that back. I might bring through that question that I was talking about before, because it's still integration and we've got a bit of time extra. And it was, I won't say it was poorly answered because again, we didn't get a whole lot of responses, but give me a sec. I'll bring it through. Here we go. So, I don't know if you guys can read that alright, but what's the value of A when the area embedded between the positive quadrant of both fx and gx is equal to 8 units squared, right? So this one brings together a whole lot of different things, but it's specifically around definite integrals. And look, I thought it was quite a difficult question to answer. And so Pruda, as much as I want to do spec, the time it takes to write the question specifically, it's just, they're quite difficult to write. So I'm happy to, if you want, I'm happy to do some like concept streams. But it's going to be a bit of work actually for me, so just let me know. I'll put a form up at the end of the stream today, and just talk to in that. Just request that a spec stream, and if there's a few people that are requesting it, I'll look into doing it. But they're going to be obviously a lot more complex than this because we get into the imaginary numbers and things like that. So, are you doing spec? Are you? So I'll just write this. Alrighty. Oh, right, okay. What, as year 11 you did as year 12 subject? Yeah, right. That's a big year 12 subject to do. And I guess it's going to help you a ton for spec, which is good. And kind of got it over and done with. So, alright, so how do we work something like this out? So, when it comes to definite integrals, we are looking at the area. Okay, so we've got two graphs, and well, it says in the question the positive quadrant, so I'm only going to be looking at the positive quadrant. Now, 4x cubed, I hope we all know that's a cubic function. So we're going to be looking at something like that there. Okay. And then what we've got here is AX, which I hope everyone knows. Geez, I hope everyone knows by now that AX is a linear equation. If not, we can go through that in a stream another time. Just shoot me a message if you need me to go over how I knew that each was a linear and which was a cubic. So this question is basically asking what's the area embedded between the positive quadrant, which is this one here, of both fx and gx. So that's this area in the middle here. That's what it's asking for. Okay. Now, to do that, we need to know what our boundary conditions are. So what is this point here? I'll mark it in green. I'm going to try and use as much color as possible, alright? For here and here. Okay, that's what we need to be looking for. They're those 2 points. Now, how do we do that? Make them equal to each other. So 4x cubed is equal to ax. Cancel out one of the x's. We have 4x squared. I'm going to change to y because I can. 4x squared is equal to a. I hope you guys know how to simplify along this. I'm moving through it a bit quickly, but I hope it's alright. X squared is equal to a on 4. X is equal to square root of a on 4. Okay. Now remember we've got a plus and minus, so there's actually two values here for x. Now, which do we disregard? I'll just wait for tag. Are we disregarding the positive or the negative one? And why? Alright, so yeah, spot on coughing. I'm gonna coughing or coughing being whatever. We're disregarding the negative. Yeah, and spot on Zorb as well. So we disregard the negative because we're in the positive quadrant, okay? So we're only, our x value here is equal to a over, where am I? Here we go. So a over 4. Now, this is kind of a difficult one because we know that there's two, whether there's another intersection point here, but why isn't it showed up here? Now this is a common error with the way we worked out. It is okay, but we've only worked out one of the points here. So what we actually need to do is go back here and we go 4x squared equals cubed equals ax. If we bring ax over the other side, 4x cubed minus ax, okay, equals 0. Okay, take x out as a common factor, and what does that leave us? X bracket 4x squared minus a. Okay, now null factor law. Hope you guys all know null factor law. We split up two products when they're equal to 0 because one of them has to equal 0. So we have x is equal to 0 and 4x squared minus a is equal to 0. Okay. Basically, when we solve this side again, we get a on 4 equals x squared. Same thing, x equals square root of a on 4. Take the positive. But we've also got an addition one here, and this is an important one. Specifically, if we don't know what the graphs look like and it's a non-calculator exam. You've just got to remember this up here is a common thread that people go down. This over here is a common thread that people go down, and you miss out on one of the intersection points. Okay, so just keep that in mind with the null factor law. We've got to just always bring the minus over and then solve it like that. So I might rub out this top bit just so you guys, it was a bit of a red herring then that I just did, but I hope that it's still all good. So we've got our two intersection points. So x is equal to 0 and x is equal to square root of a on 4. Positive. That's what's called our boundary conditions. Now what we do is we have a integration, definite integral. Alright, no worries, Ob. Yeah, thanks for joining. And yeah, as I said, this video will be up on Twitch as well on YouTube, so if you did want to follow up for the rest of it, feel free to. So that's from square root of a on 4, all the way to 0. Now, we want the integration from the area from the linear to the cubic. Okay, that's quite important, although we'll just get a negative answer at the end. From the linear, so that's ax, take away our cubic function, which is 4x cubed, right? dx, always remember dx. Okay, also up here, I don't think I did. There's also plus c. Sorry, I just remembered it now. Okay. Now, this is what's called a definite integral. We're asking for the area from the linear to the cubic function. Okay? There's another way we can write it, and sometimes it's written where we've got square root of a on 4, 0, ax minus 4x cubed, dx. Oh no, sorry, get rid of that there. dx, and then we minus it as another definite integral. But I like to just join them up as one. It makes no difference whatsoever, 4x cubed dx. It's just literally more writing to do it like this, but it's sometimes written like this, okay? So anyway, back up to the top bit. Oh, I should grab the eraser, not the... Okay, so we've got to integrate this. We integrate it going ax squared on 2 minus 4x to the 4 over 4. Yeah? Now, those cancel out, and we have our square brackets around the outside of the square root a on 4 to 0. Hope we're all good with that. If you're not all good with that, let me know in chat, but I'm going to keep moving, okay? So, we now substitute them in. Great, thanks, Coffee. We substitute them in. It's two brackets, so we go a of square root of a on 4 squared, which is helpful, always, minus the square root of a on 4 to the 4. Okay, now we've cancelled out, so I don't know why I drew it really high, but it's just, geez, I'm shaking a fair bit. Anyway, and here we go, 8, 0 over 2, which I know we can just cancel out, minus 0 to the 4, which again we can just cancel out. So what we're left with is we can simplify this square root. So that's a times a over 4 over 2 minus. Now, square root of a on 4 to the 4 is the same as saying a over 4 squared, right? Okay, because we've got a over 4 to the half, and then all of that is to the power of 4. And with our index laws, 4 times a half gives us 2, okay? So we're left with a squared over, any ideas here, but that's 8, hope that's all good, minus a squared on 16. Keep it moving. This is 2a squared over 16. Hope we know how to simplify fractions. Multiply both top and bottom by 2. 2a squared minus a squared on 16. This is the area of this function here. Okay? We know it's equal to 8 units squared. So, in the question it states, remember in the question states, the area is equal to 8 units squared. So when we're doing it, we write 8 in as a unit squared. Now we can solve for a. So, 16 by 8 is 64, 128. A squared equals 128. Although I think I have missed somewhere. Yep, cool. 128, sorry. And then a is equal to the square root of 128. Alright? Hope that's alright, guys. That's basically how we work through that answer, and it's plus or minus as well. But yeah, as I said. Alright. So, let's, I don't know, we'll take, is that okay? Has anyone got any questions? So we went through a show that question, then integration a bit. Okay, and then we go to tan, show that question, and now we've done a definite integral. Has anyone got any questions? I'll sit for about 30 seconds. We can just listen to the music and let us know if there's any questions. Again, if you're new in chat, please feel free to join in the conversation. Alrighty. I might just get a drink of water and just stretch. And then we might move on to some binomial distribution, which is quite a complex topic, I'll be honest. So let's hope we all go right. I'll just put up the question that was on my exam, that if you did want to give it a go yourself, feel free. But I'll be going through this one. I'll be going through a whole lot of detail actually with regards to binomial distribution, right down to the basics. So I kind of skipped over the basics of anti-differentiation, assuming that you guys knew it, or at least the basics. But this one I'm going to go right back to how it's taught, because it can get really confusing. Okay, so we might get started. So if you, as I said, Pooter, if you feel free to give a go to that question while I'm doing the basics, and I'll put up the answer at the end of what it is, okay? But let's go for it. So, binomial distribution. Or probability, I think it's called. But I've committed to distribution there, so I'm just going to write probability next to it, okay? So, binomial distribution / probability is all about success versus fail. Okay? Every question, you must, no matter what it is, you must say what counts as a success for this question. What is the probability that we're working for? Okay? So let's say we had a biased coin. Is biased with an E? Does that look right? Okay, anyway, biased coin. That there was a 2/3 chance to get a heads and a 1 out of 3 chance to get a tail. Right? How can we represent this if we were to flip, how do I forget that word? Flip the coin 3 times. How can we represent this? Okay, we can represent it as a tree diagram, okay? And that's basically, and the essence of a binomial distribution, you can work everything you need out with binomial distribution, any question, with a tree diagram, okay? But that will take you a long time, especially when we start getting to 10 or 12 different chances or numbers of trials, okay? So let's represent this as a tree diagram though to start with. So we've got heads and tails, and then we've got another heads and tails down here. Hope you guys know how to do a tree diagram. I won't go, that's not right. Alright, and then we go head. Have I drawn this incorrectly? I think I have. They should be down there. There you go. Heads, there we go. Tails. Heads, tails, tails, heads, heads, tails, heads, tails. I'm going to stop talking and I'll just write it instead. Okay, so along each of these lines, we're meant to put what the probability is, right? So let's say that's a 1 out of 3 and that's a 2 out of... I think I got that backwards, didn't I? Yes. So tails is 1 out of 3 chance and heads is a 2 out of 3 chance. Then we can move all the way down, 1 out of 3, 2 out of 3, 1 out of 3, and 2 out of 3. Okay? And we've got a whole bunch of different permutations here. Okay? And that's what we've got to work towards, permutations. So we can have a tails, heads, tails. We can have a tails, tails, heads. And both of those equate to having a probability of two tails, right? I hope that came through all right. So questions might state, okay, what is the probability? Let's just say that we have 3 tails, for instance. Okay. Now, the way we do this in Year 9 is we go, okay, what's 1 over 3 times 1 over 3 times 1 over 3, right? Okay, and that's 1 over 27. That's for tails, tails, tails. Okay, and what about 3 heads? Heads, heads, heads is 2 over 3 times 2 over 3 times 2 over 3, which is 8 over 27, right? So that's well and good, but these binomial questions start getting a bit more complex. So let's try and represent exactly what we did there on the calculator with binomial distribution. So we'll do it 2 ways. We'll do it manually and then we'll do calculator with binomial distribution. So manually, the binomial distribution formula, probability, formula, is n x, this is p to the power of x, and then q to the power of n minus x. Okay, now what's n? N is the number of trials. So how many times are we doing the task? For instance, this, we're flipping the heads and tails 3 times. X is how many successes. Now, to work out what we mean by successes, we need to say success is, let's say, a heads being flipped, or landing on a heads. So what is the probability of a success? What's the probability of us getting a heads just if we flick it once? It's 2 out of 3. Remember, because this is a biased coin. It's 2 over 3 chance of getting a heads. Therefore, our Q is going to be 1 over 3, which is the chance of getting a tails, or the chance of not having a success. And that's the important bit, it's the chance of not having a success. So it's just 1 minus P. Okay? So now that we've got all this, what's our N in our case? Our N is 3. And our X, how many successes do we want? 3. We want to see what happens when we get 3 heads. Okay? So we have N as 3, X as 3, and I'll explain what this means in a sec. Our P is 2 over 3 to the power of X, which is 3, and a Q is 1 over 3 to the power of N minus X. Now N minus X is 0, 3 minus 3. Okay. This bit on the right, I'm just going to do as an aside over here and then we'll bring it back, okay? The formula is N factorial over n minus x factorial times x factorial. Okay, it is confusing. We need to know it. Too bad. Sorry, but you just need to understand it and you need to remember it. So, because I don't think it's on the formula sheet. 3 minus 3 factorial. No, factorial is meant to be outside. And that's times by x, which is also 3 factorial. Now, what does factorial mean? 3 times 2 times 1. I'm only going to explain this once, so everything else I'm just going to assume everyone knows what a factorial is. 0 factorial times 3 times 2 times 1. What's 0 factorial? I'm going to wait till someone tells me in chat. What's 0 factorial equal to? Yeah, spot on, coughing. That was quick. So 0 factorial is equal to 1. So we have 3 times 2 times 1 over 1 times 3 times 2 times 1. Cancel, 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 cancel. And we're left with 1 over 1, which is 1. All of that for 1. So it will change later on, but 1 times, now 2 over 3 cubed. 2 cubed is 8, 3 cubed is 27. Times 1, because anything to the power of 0 is 1. Therefore, 8 over 27. Which when we look at it, that's right. It's up here. Okay, that's just a proof. What's called a proof. So I'm just going through and showing you exactly what the formula means, okay? I need some water. Wow. Alrighty. So, and what does that look like on the calculator? So I don't know if everyone's got the TI Inspire or whether they've got the class pad. I'm using the class pad, but we're looking for the binomial Pdf function. Okay, so we go interactive for me, distribution, discrete, and it's binomial Pdf. How many successes do we have? We want 3 successes. How many trials were there? 3 trials. And what's the probability of success? In our case, 2 over 3. And if we change that into a fraction, because apparently we don't want to change it into a fraction, even though we can. 8 over 27 as a decimal. There you go. There's our answer. So hope that's alright. Hope we're fine with that. How do we use this now with other numbers? Okay. Now let's move down a bit. I'll go over a multiple choice question after I explain this next bit, okay? So we're working with PDF at the moment, just the point distribution function, I think it's called. I should probably know what PDF stands for. And it's not that Acrobat document, Adobe document, it's point distribution function, maybe. If anyone knows, feel free to type it in chat. So, what about if I wanted the exact same scenario, but if I wanted two heads, success, okay? So 2 successes. Ooh, kind of looks like a love heart. Well, let's just erase that and put a proper U. Okay. So this isn't as simple as just going up to a tree diagram and going, okay, what permutations gives us 2 successes? Sorry, it is as simple as going up a tree diagram, but it takes some time because it could be tails, heads, heads. It could be heads, tails, heads. It could be heads, heads, tails. Okay, so we've got multiple different permutations, and trying to work out what the probability of each of those is can take quite a bit of time. So this is where we can use we can take advantage of this binomial distribution formula. Okay, so our n trial is 3. I might just rewrite the formula or copy and paste it from the top because I'm lazy. Okay, Control C and Control V down here. Okay, so what's our n trial? We've still got 3. Let's make it 5 because this is going to add a lot of complexity to this. So let's say number of trials is 5, right? Number of successes that we're looking for is only 2. Now, if we think of all the different permutations, this is exactly 2. So we could have tails, 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 heads, heads. But we could also have tails, tails, heads, tails, heads. And so on and so on and so on. There's a whole lot of different permutations here. And that's where binomial distribution really helps us. So the success probability again is 2 over 3. We're using that biased coin. And our success, we want 2. Therefore, our 1 over 3 is going to be the power of 5 minus 2, which is 3. Okay. Just a quick cheat, or not a cheat really, but something we always need to make sure of. These two numbers must always add up to, the two powers must always add up to n, which is that one there, the top value. Okay. So again, as an aside, formula n factorial over n minus x. Oh, I've just lagged, sorry. Bit of a cursive writing there now. Factorial, and I'm going to change color after this because white is boring at the moment. Let's go to red. So, 5 factorial over 5 minus 2 factorial times by 2 factorial. Right? Now, 5 times 4 times 3 times 2 times 1. Sorry, I'll just simplify this quickly. 5 factorial over 3 factorial times 2 factorial. 5 times 4 times 3 times 2 times 1. And 3 times 2 times 1. What we can do is we can cancel out the 3 times 2 times 1 from both of them. So what we're left with is 5 times 4 on the top and 2 factorial, or 2 times 1 on the bottom. If that has not made sense to anyone in chat, please let me know. I'm going to keep going because I hope it has. We're just cancelling out that for 3 factorial, okay? So that gives us 20 over 10, 20 over 2, which is 10. Okay, hope that's all good. That gives us basically a factor at the front. Then 2 over 3 to the power of 2, so we multiply by 4 over 9, multiplied by 1 over 27. Okay, 40 on the top, 9 by 27 is what? Is 303, I think it is. Is it? No, that's way off. 243 is better. Wow, I don't know what happened just then. 40 over 243. Okay, so on the calculator, let's prove it. Binomial Pdf, I'll go through the whole process. Binomial Pdf, number of successes is 2. Number of trials was 5. The probability of success was 2 over 3. What's the line do? Oh wait. 16.46%. And again, this is the confidence here. Let's hope that that's the exact same. Because I did a lot of, yay, there you go. So 40 over 243, it's just a proof that it's right. So that's how you do it on the calculator, and that's how you do it on the manually. Both of which might be expected of you in the methods exams. Alright, here's a multiple choice question. I'll open her up to everyone. Paste, no, oh, you almost got pasted entire binomial distribution. There you go. There's the poll lev if people want to join. Do this one manually, please, if you can. What's the probability of a biased dice rolling a 5? 2 times out of 3. When rolling a 5 is double the chance over the other sides. Now, depending on how everyone goes with this, I might have to explain this one because it's quite a complex one. So give it a go. So this one might take a bit of time, so I'll just get up and have a stretch. I might go fill up my water bottle. I'll be back in 1 sec. Look at it. Oh, I forgot to hide the responses, sorry, but it's all good. Let's have a look. How we go. Spot on. Alright, so the specific one, just for anyone who's doing this, maybe watching this at a later date, the specific one for this, we've got to understand that a 5 being double the chance, right? If I'll just might bring up OneNote so I can talk to this a bit. The way we work out these ones is we've got to understand there's 6 possibilities, right? 3, 4, 5, and 6 on a dice. I don't know why I wrote it down this anyway. Now, how many? If I'm just to roll this, there's a 1. We've got to think about it. There's 1 out of something chance to roll each of these numbers, but a 5 is double the chance, right? So for all of these, 5 is going to be double. Now all we need to do is count up 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 now. It's out of 7 chances, if that makes sense. The denominator is 7. Okay, and that's what we need to be working towards when we use this binomial distribution. Okay, the setup will look like this: 2 times out of 3. So 3, that'll be 2, and this will be 2 out of 7 chance. It's the power of 2, and that'll be a 5 out of 7 chance. Remember, that's the probability of everything else, and that's basically what we're solving. Okay, I won't solve it. Hopefully you guys did it. Being we got a right answer, that's great. All right, let's go for the next one. This one, have a go on your calculator. Hopefully it'll be a bit quicker. Let us know what you get. What's the probability of dice rolling as 5 6 times out of 10? When rolling a 5 is double the chance, again, over the other sides. Alright, let's give it a go on your calculator. And I'll just put up the poll again, just in case anyone new is joining chat. That's what we're working on. It's methods, binomial distribution. We've got 1 response so far. I'll give anyone else, if they're still doing it, maybe I don't know, 30 more seconds. Feel free to draw on the calculator. Good luck doing it manually. It's going to take you a while, and you're going to get some pretty big numbers. And then I'll just show you how we can do it on the calculator. So let's have a look. Responses. Yeah, spot on. Good stuff. Yay. Great work. So on the calculator, that looks like this. Binomial Pdf. Now, the number of, we want 6 times out of 10. And the probability is 2 out of 7. There you go, that 0.0297, okay? Is there a 0 there? Yeah, cool. Just making sure. Cool. And that's basically, probability is 2.97%, rolling it 6 times out of the 7, out of the 10 times, okay? So that's the same thing as working down that tree diagram and counting how many times we get 6 5s, okay? So. Does anyone need a quick break, or are we good to keep going? Let me know in chat if you're good to keep going, or if you want maybe a 2-minute break, because I know you've been sitting there listening to me for a while, and I mean, that's painful. So, let's move this up. Alrighty. Good stuff, thanks. Alrighty. So. That was binomial Pdf. We now want to look at binomial CDF, and that's compound distributive function. I'm like 90% sure. So basically what we were looking for before, and this is kind of the difference between the two. What we're looking for before is, okay, I want to know exactly, I want to know what's the probability of exactly rolling 2 heads, flipping 2 heads, or rolling exactly 6 5s. But oftentimes it's not just, we're not just wanting to know purely 6 5s. It might be 6, 7, 8, 9, 10 5s out of the 10. Not that 1 point, and that's the difference between the two. One's point, one's compound, okay? So what does that look like? So I might just go and copy and paste that tree diagram instead of having to redraw it, because, yep. let's just grab it. There we go. Let's copy that one and paste it down here. Okay, so we've got to think about it here, that if what is the probability of flipping 1 tails or less? Now what does that actually encompass? That encompasses 1 tail and therefore 2 heads, or 0 tails and 3 heads. So it encompasses 2 points, okay? And that's kind of what I want to prove with this here. That's what this proof is going to go through. So we can write that as, when we're talking about permutations, that's, I won't go through which permutations, but for instance, this one here is one. It's 1 tails and 2 heads, okay? But then we've also got the 0 tails, okay? So when we're talking about compounding distributive function, wow, it's been a bit of a day. So we're looking at the probability of x, which is the number of successes, being less than or equal to, that's greater than or equal to, let's just swap that around, less than or equal to 1. Okay, so that's the probability of x is equal to 0 plus then the probability of x is equal to 1. And that's kind of the essence of compound distribution. We have to write it as 2 different points, okay? So point distribution. So that gives us a success of 1. Oh, so we'll do the first one. A success of 0. So 0 successes. I did that the wrong spot. 0 successes out of 3. 1 out of 3 is that. It's the power of 0. And 2 out of 3 is the power of, then we've got 3 minus 0, which is 3, okay? Plus 3 trials, but we have 1 success this time. And I'm not going to run out of space, guys. 1 success. And that's 2 successes, okay? Remember, these powers need to add up to the number of trials, so that's 3. So let's keep going. If we wanted to do this manually, I'm going to do this quickly manually. So 3 prime over, prime is another word for factorial. 3 prime is 3 minus 0 prime time, we're lagging again, times 0 prime. In this case, it's going to be 3 prime on 3 prime, which equals 1. Okay? Okay, I hope that's alright. If it's not, let me know in chat. So 1 times, now 2 over 3 cubed, again, 8 on 27. Plus, now we do this other one. Let's just scroll down a bit, give myself a bit of room. 3 prime over 3 minus 1 prime times 1 prime. Okay, so that's 3 prime on 2 prime, which equals 3. Because the 2's cancel out, it just leaves us 3. Okay? Again, if it's not okay, let me know in chat, otherwise I'm going to assume it is, and let's keep going. And yeah, that's 1 over 3, and that's 4 over 9. So we're left with 8 on 27 plus 3 times 4, so that's 12 over 27. Hope that's okay. Okay. Feel like I've skipped something. But we'll just push through. Let's keep going. Okay, and then we got that is equal to 20 over 27. I might have skipped a step somewhere. If I've skipped a step and you can, I haven't gone into enough detail, let me know. I can't see where I would have, but let's just keep going. So that's saying the probability of getting a 1 tail or a 0 tails is 20 over 27. Okay? So let's check this on the calculator 2 ways. Stop. So let's go interactive. Let's go two PDFs. So success is 0, trial is 3, possibility of success, probability of success is 1 over 3. And we want to add on this same thing, but instead we have 1 success. So 0.74 20 over 27, 0.74. Okay? So that's just a proof that you can do a compound as 2 points and it still works. But now if we wanted to do it as a compound, because it's much, much, much easier, what's our lower bound? 0, because that's the lower number of successes. What's the upper bound? 1, that's the upper number of successes. Okay? Number of trials, that's 3. Yeah? Probability success, again, 1 over 3. And there you go. So all compound is doing is squashing together a whole bunch of points. Okay? We just need a lower and upper bound, and then it can just squash together those points. Okay? Hope that makes sense for everyone. So. Let's try one on Polev. Everyone? Do this one manually. Okay? I'll post the link again for Polev. Give it a go. So, what's the probability of biased dice not rolling a 5 one time or less out of 3 rolls? A 5 is double the chance over the other sides. Give it a go. So I might give you guys another minute. It is a bit of a tough one. We'll wait one more minute. Just keep listening to some music. Alrighty, we got a response. Let's have a look. Responses. 68 out of 343. I think that's right. Yeah, spot on. So I'll just pull this up manually, just how we write the formulas out, because I think that's always helpful to know. So we know that double a chance is a probability of success. Now that's the tricky bit about this one. Oh, it's meant to be a Q. The probability of success is not rolling a 5, okay? So the probability of failure is actually rolling a 5, which is different to the other question that we did. So P is actually 5 over 7, whereas Q is 2 over 7, okay? So the way we set up these equations, again, for anyone who's doing this at a later date, wants to know, what did I say? It was 2 rolls out of 3? 1 time or less out of 3 rolls. So 1 time or less. So we want probability of x is again less than or equal to 1. So we set this up. We go 3 rolls and 0 successes because it's less than or equal to 1. Success is 5 over 7 to the power of 0. 2 over 7. 2 over 7. I don't know if you guys can see the lag, but it's odd. And that's 3. Plus then, ooh, almost got me. Up you go. Alright, and here we've got 3 and 1, and 5 over 7 to the 1, and 2 over 7 is to the 2, okay? So we're saying that this is the probability that we don't get any. That we don't get any, this is probably that it happens once, okay? And then we just do this, add it up, and that's how we set it up, and we should get an answer of 68 on 343, okay? I'll give you one more, and this one's going to be on the calculator, okay? That's frustrating. Oh, sorry, one too many. Give this one a go. This one you feel free to do on the calculator. Sorry, forgot to hide it, but yeah, spot on. I think, pretty sure. Yeah, good stuff. So, how does this look on the calculator? Let's have a look. So, that's hidden. Alright, let's put it over here. So, what is the probability of a biased dice rolling 4 more than 6 times in 12 rolls? But a 4 here is triple the chance of the other side. So again, we're just gotta go back and we'll write this out. 1, 2, 3, 4, 5, 6. Now a 4 is triple, a 4 is triple the chance, so that's a 3 there. The rest of these have a 1. Add up all these, and what does that give us? 8. So all of these is 1 out of 8 now. So the probability of success, or rolling a 4, is 3 out of 8. And that's pretty important, okay? We need to know how to manipulate our probabilities. So we go interactive CDF. I don't know what it is on the TI Inspire, I'm sorry. What's a probability of more than 6 in 12 rolls? So anything more than 6. So that's from 7 to 12. It's not 6 or more, and this is also an important bit here. It's more than 6, so it does not include 6. Number of trials, and I hope I did that on that answer. I'll have to check. In 12 rolls, and the probability of success, what do we work out, is 3 out of 8. Again, back here, that's that 3 out of 8 here. Enter, there you go. 0.1178 when we round up, okay? It's always a good feeling. Get that right? Cool. So, as the last thing we'll do, because I'll just keep moving, because the last thing I want to do is actually go through this question. We did it all the way up here, because it involves a bit of a normal distribution. Come on. There we go. Now, I don't know if anyone's had a chance, but if you're watching this future date, feel free to pause it here. And you can then try and do this one yourself. It's a question I've made up, but it's of a similar nature to a practice exam from VCAR. Like obviously things have been changed in it, but along the same notion, we've got to use binomial and normal distribution, okay? So, if we read this one, students have to choose between top and bottom locker each year, okay? So we know there's 2 choices here. So as soon as we read that there's 2 choices, immediately think, okay, we're heading down binomial distribution way, okay? The probability of a student choosing a top locker is twice as probable as a bottom locker, okay? If 4 students are chosen at random, the probability that n or greater of them choose a bottom locker is 1 on 9. What's the probability that n students or less choose a top locker? Okay? This one's, actually I don't know if it's normal distribution or just normal, or just regular distribution, but let's have a read. Okay, let's have a go. I might have been thinking of a different question. But anyway, let's keep moving. So n we know is 4, because 4 students are chosen at random. Okay, let's see. This is a exam 1 question, by the way, so no calculators allowed. N is 4. Now, we know that the probability, we need to work out what the P is. So a success or a fail, what the probabilities are. What is a success in this scenario? 4 students are chosen at random, the probability that n or greater of them choose a bottom locker. So we know that success is a bottom locker. Which I don't know if, you're in high school, but you're at home at the moment, but bottom locker was definitely not the success. So top locker is twice as probable, which kind of makes sense. So we've got 3, basically we can say getting a bottom locker is 1 out of 3, and a top locker is 2 out of 3. So that's top and that's bottom. Because we can see here, the top locker is double the chance. So 66% versus 33%, okay? So I hope that makes sense. Let me know if it doesn't, but this is 1 over 3, and that's 2 over 3. Okay? So now we can work with some binomial distribution, okay? So what we've got to work out here, and this is where we get a bit lengthy with this question, okay? And what we need to work out, because we're not knowing what the x value is, because it's kind of like probably x is x students or less. So x is less. Why do I always get this wrong? You'd think someone going through this many years of maths would know the difference between greater than and less than. So, n students or less, choose a top locker. Okay. So, yeah, this question's a bit all over the place, but I'm just gonna push through because it's quite a complex question. So we need to work out the probabilities of success and failure and things like that for each x value, for each numbers of successes. So if n equals 4, okay, I probably shouldn't have used n twice in the question, but we'll keep going. X equals 0. What does this look like? This looks like 4, 0. Success is 1 over 3 to the power of 0, and a failure is 2 over 3 to the power of 4. Okay. Now, if we were to work this out, I'll work out 1, and then for the rest of them I won't work out. 4 factorial over 4 factorial minus 0 factorial, which gives us 1, times 1 over 3 times, and what's this? 16 over 81? Yeah, 16 over 81, which gives us, how have we worked? Sorry, I just realized. That's meant to be 1, because anything to the power of 0 is 1. So that is 16 over 81. So the probability that the 4 students all chose a top locker, because there's no successes for the bottom locker, probably that they all chose a top locker is 16 over 81. So it's pretty probable. We do the same thing with x equals 1. What's the probability that one person chose a bottom locker and therefore 3 people choose a top locker? 4, 0, 1 over 3 to the 1, and 2 over 3 to the 2. Again, pause it here if you want to work this out yourself, but the answer for this one, 24 over 81. Very, very similar way to do this. I'm going to have to do this 5 times, so I don't want to have to, you get it. We look at n equals 4, x equals 2. 2 people choose a top, 2 people therefore have chosen a bottom. Write this out the same way. 1 over 3 to the power of 2, 2 over 3 to the power of 2. Gives us an answer of 24. I think that one's not right. That one's meant to be... Sorry, I'm looking at... I'll be honest. I am looking at my previous working for this one. I don't do all these equations in my head. That one's 32, sorry. And this one's meant to be a 24 on 81. Apologies if you had paused the stream and now trying to work out furiously why your answer was wrong. It was right. Okay. So x equals 0, x equals 1, x equals 2. Now we'll look at x equals 3. And silly me, I have gone all over the place, haven't I? That's a 3, that's a 1, and that's a 2. Apologies for all of that. Yeah, I don't know why. Maybe it's after 3 hours of tutoring. So 4 and 3 here. 1 over 3, 3. And therefore that's 2 over 3 to the 1. Okay, and that gives us a value of 8 over 81. Alright. Last one, n equals 4. X is also equal to 4. So this is if all of the students that we chose at random, if they all chose a bottom locker. Okay, so that's 4 and 4. And I'll be honest, I think it's forced a bottom locker. So that's the 4. And 2 over 3 to the 0. And that is 1 over 81. Okay, so what should all of these add up to? 16, 32, 24, 8, 8, and 1. They should add up to 81 over 81, because this should be covering all of them. It should be covering if they 1 person, 2 person, 3, 4, or none chose a bottom locker. Okay, so and let's just quickly do that. 16, 32 is 48, plus 24 is 72, plus 9 is 81. Alright, so we can just confirm. It's a good way of stopping halfway and going, okay, am I on the right track here? Which, good news, you are. So now we have to put this in a table. Okay. It's a big table. No, oh, I'll just leave it, that's fine. So this is the number of successes and the probability of that success. Okay? So I think that's meant to be a little x at the top, by the way. Alright? So if we've got the probability of 0 success, 1 success, 2 successes, 3 successes, or 4 successes. Alright? If we move up, it was 16, 32, 24, 8. 16 over 81. I really should have gone one by one. 32. 24. 8. And 1. Okay? So, what all this table has done is just told us what's the probability of each success. Now remember, this is very important for this question. Success, I'm going to write big because it's that important. Success equals bottom locker. I should have just left it at the bottom. Alright, anyway. Success is equal to bottom locker. If we go up and we have a read of the question, I might just copy and paste the question down the bottom. Because this is kind of a trick that can be done. If 4 students are chosen at random, the probability that n or greater of them chose a bottom locker is 1 over 9. What's the probability that n students or less choose a top locker, okay? So, what we've got to work out here is what numbers here add up to 1 over 9? What numbers in the bottom row add up to 1 over 9? Okay, just pause it and give it a go, but I'll keep going. It's these two on the end. Okay, so that's saying that 8 over 81 plus 1 over 81 is equal to 9 over 81, which is equal to 1 over 9. Now this is just a kind of a, you just got to know this. You got to know that how to work with fractions. 1 over 9, if we convert it to 81, is 9 over 81. And therefore we can work with it a lot easier, okay? So, that's, if we now reread this, the probability that n or greater of them choose a bottom locker. So, we're now just looking at this bit here. N or greater. So therefore n, in our case, and that's this n, again, they try and trip you up. This n is different to the number of trials, okay? So we're now looking for how many, what's the probability that 3 or less students choose a top locker, okay? So all that entire top part, all that it has done is told us what to look for at the very, very bottom, okay? We're looking for 3 or less students. I hope that makes sense to everyone. Okay, that entire top part, all it was trying to do is getting us what this value is, that n value of 3. So now, we've got to do one more binomial distribution that I'll do all by hand. Still, there is 4 trials. 3 of them is successes. Now, what's the success change to in this case? Success equals the top locker, which we now know, we know from 4 is 2 over 3 to the power of 3, 1 over 3 to the power of 1. Okay, now we could just use 1 from up there, but I'll just do it by hand because it just seems to be like, you know, finishing with a, I'll stop talking, 4 prime over 4 minus 3 prime, and then we multiply that by 3 prime. Multiply that by what's 2 over 3 cubed, it's 8 over 27 times 1 over 3. Okay. So that is for 3 students. Now, the issue, I've just realized there's a glaring issue in what I've done here. Because this is 3 students choosing a top locker, then we've got to go 2 students, then 1 student and 0 students. And I'll be honest with all of you, I don't want to do all of those calculations. So, here's a different hint. And I thought I wasn't going to go over this, but apparently I am. it said that if success is top and it's looking for the probability of x being have I done that the right way again? No. In students or less. Again. Probability of n students or less choosing a top locker. So therefore, we want 0, 1, 2, 3 students choosing a top locker. But what we can do with binomial distribution a bit is saying, okay, because there's only two choices, let's think about it. If 3 students are choosing a top, 1 student is choosing a bottom, right? 2 students are choosing a top. 2 students choosing a bottom. 1 top, 3 at the bottom, and 0 at the top, 4 at the bottom. Okay, so that's looking at all of these ones. So what we can do, there's 2 things we can do. We can grab all of the values here for the successes of the bottom locker, if that makes sense. So we can grab, see how this is a 1 bottom, therefore that's going to be up here as a 1 bottom. Here's a 2 bottom, we can grab here, 3 bottom. Hey Ruby, thanks for following. And that's a 3 bottom, and 0 at 0 top, therefore it's a 4 bottom. So we can transplant, and this is kind of where these questions get confusing because successes are changing, but we can still work them out with the binomial distribution because a 3 success of a top is the exact same thing as saying a 1 success at the bottom. See how they're kind of like opposite of each other? And that's what we can do. So we can say here is 32 over 81. This one is, I think, 24 over 81, if we just scroll up and have a look. Yep, this one's 8 over 81. And this is 1 over 81, okay? And they're added up all together. And that gives us, I'm not going to do it on a calculator because I'm not allowed to calculate it, which is good. So 32 and 24 is 56, plus 9 is 65 over 81. So I'm going to just now pause for about a minute. If anyone has any questions about what I did up there, because there was a couple of points where I thought I was going down one path, but I changed it to a different path, let me know in chat and I'll go over it again, those specific points. But if not, I think we'll finish up the stream because that should be around an hour and a half. So I'll just pause for a minute and then I'll talk about some other stuff, okay? Alrighty. So this doesn't look like there's any questions, so hopefully that all makes sense. If you are watching this at a later date, there we go, and want to shoot us a question about anything I've done, I'll post an email. You can shoot us a message at just shoot us a message there and I can go over some things to explain. Or there's a contact form on the website, Test Me Tutoring, where you can also access our exams. They're free practice exams, just to help you guys out. There's a contact form there, so that's testmetutoring.com.au. You can ask us some things there. If you are watching this at a later date, I'll put up a form. I'm not sure how it looks. I think it's just a video, so it's going to be difficult for you guys to access the form. But I'll put it in chat now. It's basically just a feedback form for me on how this stream went. If you could fill it out, that would be fantastic. So I'll be running this every 2 weeks for methods. There's also a further stream that starts at 12. They roughly go for an hour and a half each. I'm trying to limit them. They used to go for 2. The first one I did was for 2 hours, and it was just too much. Too much content to go over in 2 hours, and I feel like it's really hard to concentrate on a Sunday especially. So I'll hang around. I'm happy to talk about uni, talk about preferences, talk about methods, talk about any other topics. Feel free to fill out that form, please. It would be fantastic. The new exam will be up you can sign up to the website to get access to those. Give us a like on Facebook, follow us on Twitch. We've got a YouTube channel, Twitter, just any of the social pubs you choose. Yeah, it would be great. And yeah, so let us know if there's anything else. I'll hang around for another 5 or so minutes and then I'll let you go. So yeah, just to ask us a question in chat. Just again, I did engineering and science at uni, so if there's any questions around those, happy to help, because I know preferences are coming up as well. So no worries, Puffing. Thanks for joining in. Yeah, that'd be good. That last one around binomial probability got a bit difficult. So again, it was a similar question to what was in VCAR exam. I've modified it as well a lot, but it's that kind of, you're working with two kinds of probabilities here. So you got binomial, and then you need to work with how you can use that binomial to solve another issue, another problem. So if anyone's got any opinions on any subjects, other topics they want to cover in methods, please shoot us an email, or a message on Facebook, or a contact form on the website. But yeah, 2 weeks, another stream, same time, and yeah, feel free to do some of the exams and upload. I'll be doing corrections for the methods exams, so please take advantage of that. I'll help you out with full consequential marking and give you some feedback as well. So feel free to do that. Alright, thanks a lot, guys. Have a good rest of the day and have a good rest of the weekend, and only 2 more weeks left of holidays, so until holidays, so good luck. See y'all.